and welcome. Your third video, okay? Getting the hang of it. This will be good. This one should be shorter. This one doesn't have as many examples, and we don't have to do as much work. So let's go ahead and talk about exponential equations. Let's go take a look. So, hey, today you guys are going to learn about, how to generate and solve exponential equations mathematically in real-world problems. Real-world problems. Those are good. Okay, the student will use mathematical language to solve exponential equations. In other words, you're going to talk about things using math terms. So let's go ahead next. So one of our key concepts that we need to talk about is why can we solve exponential equations? And the reason why we can solve any equations is because everything, it's a one-to-one function. Well, what do you mean one-to-one function? Well, that means that on my graph, when we were graphing logs, here is our graph, and our exponentials, excuse me. And our exponential graph did something like this. And it doesn't fold in on itself. It's not a U shape there. For every one x value, it has one y value, and vice versa. For every one y value, it has one x value. And so what does that give us the power to do or say? It tells us that, well, if I have something like this where it's 3 to some power is equal to 3 to the 5th, well, if they're equal, I can easily just say x is now equal to 5. Okay? I was like, duh. Alright. And finally, the other one is if I have something that says, hey, log base 10 of x is equal to 3. Then I can do something to undo the log. Well, what can I do to undo log? I could raise it to an exponent. Well, what does that mean? Well, I can go ahead and say my base is 10, so if I raise everything here to 10 log x is equal to 10 to the third, well, what can I do with that? Well, remember when we talked about how the exponential and the log are undoing of each other, like subtraction and division? Well, if the log has the same base as my exponent, or my exponential, 10, and then they essentially kind of quote-unquote cancel out, but they don't cancel their inverses of each other. Okay, it's like taking 6x and dividing by 6. Okay, so this right here means that this is just x is equal to 10 to the third, which is 1,000. So yay, we solved our first one. So let's see how we can use some of these in these equations. Let's go and hit next. So solve 4x plus 2 is equal to 16x minus 3. In order to solve these, one of our key things that we need to have is the same base. Well, we have 4 as a base and we have 16 as a base. They're not the same. So I want to find a way to get 16 and 4 to have the same base. Well, what I do know is that 4 squared is equal to 16, right? So if instead of 16 I now have 4 squared, so here I have 4x plus a 2 is equal to a 4 squared. Now how do I treat it with that x minus 3? It's a multiply. Okay. And I can go ahead and solve from here. Now I see I have the same base. The step that I'm doing, in order to, since I have the same base and set them equal to each other, the actual math step is I'm taking the log to both sides. So really what I have is log of 4x, base 4 of x plus 2 is equal to log base 4 of 4 times 2 times x minus 3. That's the actual math step. I'm not just going, well, duh, they equal each other. Okay? And like I said, base 4, base 4, base 4, base 4, it kind of undoes each other. So that means what I'm left over is my exponents, which is x plus 2 is equal to, and I'm just going to multiply this out, 2x minus 3. Subtract an x from both sides. Okay, subtract x from both sides. Add a 3 to both sides. And I end up getting that 5 is equal to x. Now, you can always check your answer, but it is not necessary on the exponentials because I can't have negative exponents, right? Negative exponents are okay. Let's go see what's next. It says solve 1/3 n. 1/3 of the n is equal to 1 over 81 to the 2/3. Okay. Again, how do I do this? What's a common base? And this is where we have to sit here and talk about, okay, remember we have to talk about, okay, if I have 3, 1/3, I can write this as an exponential. Okay, I can come off to the side and I can say, well, 1/3 is really the same thing as saying 3 to the negative first power. You need to be comfortable with this. This will help you out in the future. So when I say that, it's 3 to the negative first power times an n is equal to, 81. Well, hopefully you remember that 81 is 9 times 9, and each 9 is 3 times 3. So that means there's a total of 4 3s, and it's in a denominator. So that means I have 3 to the negative 4 is the 1 over 81 times the 2/3. I can go ahead and multiply things out. I got 3 to the negative n is equal to a negative 3 to the negative 8/3. Again, what I'm really going to do is take the log of base 3 to both sides. When I take the log of base 3 to both sides, the 3 cancels out, or the exponentials, excuse me, they don't cancel out. The exponents are left to be equal. Negative n is then equal to a negative 8/3. Divide by a negative 1, n is equal to 8/3. So our key point on this one is being able to write fractions as exponents as well. Okay. So solve for 3x equals 7, round to the nearest hundredth. It's like, oh, good golly. Well, what do I do? Remember, I don't have a common base now. So we go back to what we talked about. How can I get the x brought down? Okay. What did I do to both sides to bring the x down? What was the thing that I did to both sides before? Oh, log of my base. So in this case, my base is 3. So if I take log of the same base, 3, of 3 to the x, I need to do the same thing to the other side. I'm trying to undo an exponent, or an exponential. When I undo that, that means I got to do this to the same side, base 7. Okay, and well then what do I do with this? Well, same base, my exponent's left to be on its own is equal to, well, log base 3 of 7. But I can't put this in my calculator. What can I put in my calculator? You know, remember our change of base. Our change of base says this is log base 10 of 7 over log base 10 of 3. And now I can go ahead and put that in my calculator and see what I get for an answer. And the answer that I do get is equal to, after putting in my calculator, 1.77. Ta-da. Okay, so let's see what's next. Ooh, solve e to the 2x plus 1 equals 8. Round to the nearest hundredth. Okay, again, I don't like the x's above. I want to bring them down. So how can I bring them down? Okay, well, I wanted to undo the exponent part. Well, undoing the exponent means I need to take a log. Log of what base? Log of the same base that I had before. The same base of e. Oh, we have a special log for that one. If I take the natural log of both sides, e to the 2x plus 1 is equal to the natural log of 8. That means that these end up being inverses of each other, so that my exponent is left alone of natural log of 8. And I just solve for x like normal. Why? Because this is a number. Okay, gotta get past the letters being there. It's just a number. If I can put that in my calculator and get a number. So if I subtract 1 from each side, divide by 2, I get x is equal to natural log of 8 minus 1, all divided by 2. And when I put that in my calculator, I get 0.539, but they want to round to the nearest hundredth, which means that it's going to be 0.54. Okay, so it's not horrible, guys. It's just a new step to put in your toolbox of how to get the x by itself. Okay, so let's see what we got next. Okay, now this one gets to be a little bit difficult. You're like, ah! Alright, so we're going to work through this kind of together, mainly with me, right? Because I'm on the video. So let's take a look at this. We've seen something that looks like this before, right? We've seen stuff that, hey, it's kind of like an x squared plus an x. Okay, well, let's just write it out like what it's x squared minus an x minus a 2. And it is. It's exactly the same. So if you want to rewrite it like this and come up here and say, well, we're just going to pretend that x is equal to e to the x. Okay? And I ask myself, hey, self, what two numbers multiply to be negative 2 but add up to be negative 1? Well, the x, see here, minus a 2, x plus a 1 is equal to 0. And then we'd solve for both sides, right? We'd set it up to where we would say x minus 2 is equal to 0 and x plus 1 is equal to 0. But this is where we have to stop and go, oh, wait. What was x? X was this stuff up here. X was really e to the x for our original problem. So if I say this, I say, well, this is e to the x minus 2 is equal to 0. And this is e to the x plus 1 is equal to 0. And I start solving. Okay, well, I come over here. E to the x is equal to 2. And e to the x is equal to negative 1. So what do we do to get rid of that e? Oh, okay, so that was where we have to go. Well, wait a second. So we're going to take the natural log of both sides, right? E to the x is equal to natural log of 2. This is natural log of e to the x is equal to natural log of negative 1. Over here, my x goes away, but this part here, my exponential is able to come down. It's equal to natural log of 2. And then I get to this part over here and I see, what do I have here? Ah! Natural log to negative. Oh gosh, natural log of a negative number. We can't do that. No. So at that point, I say, nope. That's not a way to get a possible answer. This is my only answer. And I'm done. Okay. Here we go. And I say, let's go. Boom. Okay. This is what you need. These three formulas, they'll be on your formula chart. And we're going to go ahead and use them today. We're not going to use all of them, but you need to be aware that these three formulas will be available to you on a formula chart. And the one that we're going to really pay attention to a whole lot is this right down here. Not only is this for half-life formula, but this is also for, okay, exponential growth. All right, let's talk about what each of these are. Okay, each of these things are. E is just E. Okay, T, no, let's go over here and use a different color so you can see this better. T is usually time. Okay, here's the kicker. K is a constant. What does a constant mean? That means it is a number. It's usually a number we don't know and we have to find out. And last but not least, let's go ahead and take this here. A sub O is our initial amount. Okay, initial amount. Here's how we use this. Next. I have a formula here. It says this table shows the number of cell phones at the new store sold in March and August of the same year. If the number of phones sold per month is increasing at an exponential rate, identify the continuous rate of growth. Okay. When they talk about, okay, here's your keyword, exponential rate. All of a sudden you need to go up and find your formula chart for that one that says decay, and it's also for exponential growth, is equal to A sub O e to the k t. Next, we need to identify, it says identify the continuous rate of growth. The continuous rate of growth is k. Then write the exponential equation to model this situation. All right. So here's how we do this. Usually they're going to give us 2 data points. And what you're usually going to do is your first data point, your time. So here I'm going to set up t, will always be 0. And your second time, you have to figure out what that is compared to 0. So March, you got April, May, June, July, August. So that's 4. And the number sold is 88 and 77. This right here, the number sold, is going to be your A. All right. 88, since it's with 0, that's your A sub O. Okay. So now I start plugging in what I have. I know that on the 4th month, I had 177. When I first started, I had 88 sold. E to the k, and again, this happened in the 4th month. All right. And what's the key about finding your k is that k is very little changes to k have a huge difference to actual answers. So what you want to do is keep everything in fraction form for as long as possible before you find out what k is. So here we go. I divide both sides by 88. I have 177 over 88 is equal to e to the kt. But t in this case is 4. Okay. Again, so how do I get rid of, I have k up there, I want to solve for it. So I want to bring it down. So to bring it down, I got to go ahead and take the natural log of both sides. So I have the natural log of 177 over 88 is equal to, because I'm short on room, when I take the natural log of that, remember it's going to go k4, and I'm going to rewrite it as 4k. And then finally, I'm going to go ahead and solve this. I'm going to say that k, by dividing by 4, is equal to the natural log 177 over 88, all divided by 4. And we keep it that way. Okay? We do not, excuse me, we do not make it, put it in the formula right now or into the calculator right now. Now, if they ask for it, sure, go ahead and find it out what it is in the calculator, put it in there. Okay, but that's your exact answer. We need to keep it that way. Why? For the next problem. And this is our last one. This same table, everything this, we're going to use our model to predict. So what was our model? Well, our model was A is equal to A sub O, which we said was 88. E to the K, well, what was K? Ln, the 88 over, oh, not 88, of 177 over 88, all over 4 times T. And they want to know how long will it take to sell the store 500 phones in 1 month. Okay, so again, which one are we looking for? We're looking for the predict the number of months it'll take. So the number of months, that's my time. 500 phones is my A, so I just set it up. 500 equals 88 E, the natural log of 177 over 88 all over 4 times T. And now I solve. Okay. So what is this going to look like? Divide by 88. 500 over 88 is equal to E to the natural log of 177 over 88 all over 4 times T. Oh my goodness. So now what do? Take the natural log of both sides because I want to get rid of the E and bring my exponent down. So now I have natural log of 500 over 88 is equal to the natural log of 177 over 88 all over 4 times T. And now I divide. And I'm going to pause and show you the answer real quick. And that will be that. So after finding the natural log of 500 over 88, multiplying by both sides by 4, dividing by the natural log of 177 over 88, I get an answer of T is equal to 9.944. Please take the time to, with your calculator, see if you can replicate this. If you can, okay. If you can't, if you don't have the calculator to do it now, come back tomorrow and put that in there. Okay. So then I go ahead and I look at all this, and I go time is equal to that. Great. And so it says number of months. There it is. That's the end. All right. Here we go. See you guys tomorrow.